Let's think about the advantages and disadvantages of Flash ADCs in this particular video. We've already looked at Flash ADCs, and what we have seen is that it's basically made up of comparators. And once you have this comparator, you get a thermometer code here. And once you get a thermometer code here, that can be converted into a binary code. One of the main advantages of a Flash ADC is that it's very fast, right? Because in one go, you do the comparison, all the comparisons that you have to do, and you get the signal. So it's just one comparison that you require. The major disadvantage is that you need quite a lot of comparators. So for a 3-bit conversion, you required 7 comparators here. Imagine if you had to do an 8-bit conversion, you would require 255 comparators. For a 16-bit conversion, you will require 65,535 comparators. And so, as you can see, the size of your circuit increases exponentially with the number of bits. So that becomes one of the major problems with Flash ADCs. Of course, once there are a lot of comparators, then you have issues with driving all of them because you require a lot of power to drive all the comparators. And then you will have issues of bias currents on each of these comparators. Bias currents are currents. So when we usually say that there is zero current going into the comparator, but it's not exactly zero. It's a small current. But as you increase the number of comparators that you're using, it requires large amounts of current, and that causes some kinds of issues. So those are some of the disadvantages of a Flash ADC. And the main advantage, of course, is its speed, right? Okay, another disadvantage of the Flash ADC that we talked about with a 1-bit ADC as well was metastability. Let's see how metastability creates problems in a Flash ADC. So here's a Flash ADC. You have some comparators here. And so you have these string of resistors generating different reference voltages, and it's being compared, right? So let's say your analog value is equal to the reference at this point. Okay, I should turn on my laser. Okay, so the analog value that is coming here, analog input, is equal to the reference at this point. Okay, so if that is the case, all the comparators below that would just give you a 1. Okay, they are on, or they give you a 1 or something like that. And all the comparators above that give you a 0. They are off. Okay, but this comparator gives you an unknown signal. Now here's a decoder. This thing is doing a decoding of these signals. And when you have a decoder, you can see that what happens is, as you combine this undefined output with the output of this comparator and the output of this comparator, more and more inputs start to become undefined. And therefore, the binary code that you get is quite undefined. Okay, and that is the issue with metastability. So the undefined character of your comparator output affects your decoder and therefore your digital output completely. And that's one more disadvantage of Flash ADCs. Of course, this would be one of the things that also creates problems with increasing the speed of your Flash ADCs, which is one of the advantages of a Flash ADC. The reason why you want to use a Flash ADC is because of its speed, but then the speed is limited by metastability. So in summary, the main advantage of Flash ADCs is speed, while the disadvantages is basically revolving around the high number of components that we want to use. And because of the high number of components, we usually cannot use Flash ADCs for higher resolutions. You have high powers. They are expensive because of the component count. And then you need a high current voltage reference, basically because all the comparators draw a little bit current, and therefore your voltage references need to give up enough current. And then there are errors due to metastability.